Hi everyone, welcome. This question, first bad version, says you have n versions, 1, 2, 3 to n, and you want to find out the first bad one. You also have a function called is bad version or not. And the proof for solution such as here has a linear time complexity or n. It wouldn't be efficient when n is extremely large. So how can we improve the efficiency? How can we improve on efficiency? Well, we can use the binary search algorithm, which reduces the original problem to roughly half the original size each time. Therefore, it has a time complexity O of n. What do we mean? Well, consider this test example has A versions, and we use two indexes to point to the first version and the last version. Here the index also means the version. And we want to cut the A version in half by testing the middle version to see if it's a bad version or not. In this case, it's not a bad version. So we know all the previous version, we don't need to look at them anymore. And then we can move the left index to the immediate right of the middle element. And then repeat that process. And we cut this remaining part in half again, and so on. In contrast, if the middle element is truly a bad version, and we are pretty sure all the follow-up version must be bad, and there's no need to look at it anymore. So we reduce the problem to only the left half chunk, because we still don't know where the bad begins. But at least we know the middle element is bad. So we move the right index to the middle element. One way to understand the workflow is by visualizing them in this decision tree-like process. As you can see, we begin with 8 elements, and then we reduce the problem into half to 4 elements in this first step. In the next step, we further reduce it to only 2 elements. Finally, we reduce it to just 1 element, and in this step, we have the left and right to be the same. So when we have left and right to be the same, we can return either of them as our answer. With all the background knowledge introduced, we are now ready to write the code. So first of all, we define the left and the right versions as the lowest and highest possibilities. And then while these two versions are not the same, because once they are the same, means we already arrived at our answer, and either of them can be the right answer. But while they are not the same, we calculate the middle version as the sum of left and right floor divided by 2. And if the middle version is a bad version, then we know anything after the middle version is always bad. But we still don't know where it started. So we set it right to be the mid. On the other hand, if the mid version is not bad, so we know all the previous versions is also not bad, so we don't need to look at them anymore, and then we can save the left to be mid plus 1, and we reduce that window to half this way. So finally, left will be the same as right, and when this loop is done, we just return either the left or the right, like the same. And we submit this to see how it works. Submit. So it's accepted with 16 milliseconds. Pretty good. And now we analyze the time complexity. So the time complexity, since we use the binary search, so O log n This means if we have like this number of versions, on average, we just need to ask the question 99 times. And the space complexity will be O1 since we use the constant space here. Thank you.